This week on the show, we cover scheduling in NetBSD. We have a ZFS versus RAID on the Ironwolf disks, OpenBSD on Microsoft Surface Go, FreeBSD for Linux sysadmins, FreeBSD on the Lenovo T480, and more. In this week's episode, BSD Now. BSD Now, episode 353, ZFS on Ironwolf, recorded on the 6th of June 3rd, 2020. This episode is sponsored by Tarsnap, tarsnap.com. Hello, I'm your host, Benedict Reuschling.
And I'm Alan Jude.
Welcome to this week's episode. We're happy that you're listening in again. We have great headlines for you as always, and we're starting off with scheduling in NetBSD, part 1. So this is about the scheduling, of course, in NetBSD, and it's part of a series. So this is part 1, but we'll cover the other ones later or in a future episode. So the introduction reads, in this blog, we will discuss about the 4.4 BSD thread scheduler, one of the 2 schedulers in NetBSD and a few operating system APIs that can be used to control the schedulers and get information while executing. Then it talks about a few basics. So what is a scheduler? So this is the elephant in the room. Process scheduler schedules the processes of different states, namely ready, waiting, and running. There are different scheduling algorithms like shortest job first, first come, first serve, shortest remaining time first, priority scheduling, round robin, and multi-level queue scheduling. These algorithms are either non-preemptive or preemptive. In preemptive scheduling, it's based on the priority, where a scheduler may preempt a low priority running process anytime when a high priority process enters into a read state. Whereas in non-preemptive scheduling, once a process enters running state, it cannot be preempted until it completes its allotted time. Talks a little bit about processes, what NetBSD defines as a process. It's basically the textbook process. NetBSD supports traditional processes created by fork, native POSIX threads, P-threads. These threads are implemented with a 1-to-1 threading model where each user thread, or P-thread, has a kernel thread called a lightweight process. So inside the kernel, both processes and the threads are implemented as lightweight processes and are served the same by the scheduler. Then there's a part about scheduling classes and specifically about the CSF, the Common Scheduler Framework. And it describes that they were introduced in NetBSD 5.0, provides an interface for implementing different thread scheduling algorithms, and one among the schedulers can be selected at compile time. There are 2 schedulers currently, 4.4 BSD thread scheduler, that's the topic of this blog post, and the M2 scheduler, which is a more advanced thread scheduler and part of probably part 2. There's a couple of things that are controlling the scheduling of processes and threads that are described below. There are, for example, sctctl, which is a command that you can run, used to control the scheduling of processes and threads. It also returns information about the current scheduling parameters of the process or thread. This enables to monitor and control scheduling in NetBSD, including changing priority, affinity, the scheduler's policy, etc. And there's a couple of examples on the command line that you can run. There's also CPU-CTL, which can be used to control the CPU of the computer and can perform several operations like sending a CPU offline and bringing it back online, setting microcode and listing available CPUs. There are examples for those as well. And then there's a diagram for the working of the BSD scheduler on the website. We've linked in our show notes, where you can see how the threads are queued into the dispatcher and then scheduled out to the CPUs. And if there's a timeout, then a new thread has a chance to get the CPU. Then it talks a little bit about multi-level feedback queues, the niceness of a process, and the priority, and the different priority levels or the values it can take. Further down, there's a calculating priority part, where you can say, what kind of priority does this thread get? Or is there some kind of formula to it? And it turns out there are. And the mathematics is described here in detail. Oh, that's very nice. So you can kind of see that the scheduler is an important part of the operating system. And it's can be complicated, but basic concepts are always the same. Fairly scheduling the processes that are all vying for control of the CPU or CPUs, multiple of them in the system. Very nice. And I think we will cover the second part for the M2 scheduler in the future episode.
Yeah, if you're interested in schedulers, it's definitely worth checking out.
The next, we have some kind of shootout or comparison. This is ZFS versus RAID. 8 Ironwolf disks, 2 file systems, 1 winner.
Yep. So this is over at Ars Technica by our friend Jim Salter. And he's been doing a series. There's a couple that come before this on a little bit of background on ZFS. So if you're new to ZFS, those are worth reading. But also, yeah, so he's got these 8 disks and he started testing them with different configurations, looking at different types of RAID on Linux, like MD RAID 10 and MD RAID 6 and so on, but also throwing ZFS in the mix and applying his expertise there. So in this one, he starts by talking about the machine he has, which is basically a Ryzen 7 2700X with 64 gigs of RAM and an LSI 9300-8i host bus adapter that is connected to those 8 12 terabyte Seagate Ironwolf disks, and then using that and testing some different configurations. So, the first thing he talks about is how when you create a pool out of 8 12 terabyte disks with ZFS, it takes a second or two. And if you do it with many other file systems, it can take rather a long time while you wait for it to, actually format the file system and so on. And he also talks about the differences between, ZFS and conventional RAID and how it's different, and even gets into, his pet peeve about megabytes and mebibytes. But then he starts with the actual testing using FIO. In the earlier article where he tested basically just different configurations, but that were almost the same, he also tried, adjusting the number of CPU threads and so on, but found there wasn't that big of a difference. So to avoid having to do, 800 different combinations of tests, he's mostly just doing 8 FIO jobs, each keeping an IOQ depth of 8 going. So in his first example here, you can see if you're doing 1 megabyte asynchronous writes, you can see how by growing the size of your VDEV, by making it wider, you can maybe get more throughput. As you get more separate VDEVs, you get more performance. So in his example here, if you create an 8 disk pool with no redundancy, then yes, ZFS with the default record size of 128K and so on, could get you about 700% performance over a single disk by using 8 disks. Whereas, when you use just 4 disks, you get about 400% performance, and so on. You can kind of see the diminishing returns as you get too high up. Or if you do mirror sets, then you can see, again, linear growth as you get more separate VDEVs. But obviously, if you're doing mirrors, with 8 disks, the most VDEVs you can have is 4 pairs, right? And comparing that. And then he looked at some RAID Z configurations and sees that, the performance isn't quite as good. But then when you look at 4K writes, you see that the performance goes down quite a bit, where with even 8 disks, you struggle to get 400% performance compared to 1 disk. Because, you're asking ZFS to do a lot more work, and also you're actually writing more data in the end. Because if you're doing a bunch of these 4K writes to with a 128K record size, then you end up, writing to the middle of that 128K somewhere, where ZFS has to read it, modify the middle, and write the whole thing back. So you might have done, 128K read and then 128K write just to change that 4K for each one, and that can get quite expensive. But he does test with the correct record size later to show what the difference is. And then it also compares read throughput. Obviously, there's no difference between synchronous and asynchronous reads in this case, because you don't really have asynchronous reads. Yeah, so he's got lots of different results here and starts comparing it to MD RAID and single disks using an ext4 and so on. And you can see that for write throughput, again, as you get more drives, ZFS is giving you more performance, whereas MD RAID doesn't actually seem to get much faster even when you give it more disks, because your normal RAID 5 and 6 are kind of done in columns, whereas ZFS is done as rows. And so it doesn't necessarily spin up as many of the disks, or the disks aren't working in the same kind of lockstep. And so, ZFS has always been very good about writes. ZFS is completely tuned to be able to make the writes work well. And then, reads are as fast as they happen to be. But you can see in all of the write cases, RAID Z is miles ahead of other RAID. Although on the read side, ZFS sometimes suffers because you have to read the block pointer before you can know where the block is to go read it. And you can end up having to do more seeking and just dependent reads where you have to read this before you even know what the next thing you need to read is. And that can impact read performance a bit. But lots of good graphs here showing very interesting performance characteristics of the different configurations. Later on, he actually gets to doing those tests again, but with the record size set correctly. And then suddenly ZFS is just taking off with your 8-disk array here topping over 900 megabytes a second of write throughput, or even still getting over 250 with synchronous writes.
Ooh, yeah. Very nice.
Yeah, so using larger records gives you even more performance on ZFS, and tuning for the smaller records can avoid that write amplification, right? When you want to change 4K, you only have to change 4K, not 128K. And its metadata. And yeah, there's even more tuning you could do to try to cheat some of these, like maybe disabling the prefetch or increasing the size of the buffers on the ZFetch, or turning off redundant metadata and a bunch of other things. But part of this test is also to be, out of the box ZFS versus MD RAID, not just how fast can we tune ZFS to make Linux look bad or make MD RAID look bad. But anyway, so Jim's got a whole series on this. He just actually put out another one today about MD RAID by disabling its bitmap feature, which takes away some of its usefulness, but it's definitely worth checking out. And if you like Jim's work and so on, you should also check out Jim and I do a podcast together with Joe Resington, 2.5admins.com. So 2.5admins.com is our biweekly podcast where we mostly just rant about things. It's much less structured than this podcast.
You mean we don't rant
just,
here?
Jim and I being cranky old people.
Oh, okay. All right. That's good to know in case you run out of podcasts to listen to. Then you can definitely give 2.5.
Plus
is it 2.5 admins or 2.5 admins?
Mm-hmm.
So, time for the news roundup this week. We have an article about OpenBSD on the Microsoft Surface Go 2 by Joshua Stein. Goes like this. I used OpenBSD on the original Surface Go back in 2018, and many things worked with the big section of the internal Atheros Wi-Fi. This meant I had to keep it tethered to a USB-C dock for Ethernet, or use a small USB-A Wi-Fi dongle plugged into a less than small USB-A to USB-C adapter. Microsoft has switched to Intel Wi-Fi chips on their recent Surface devices, making the Surface Go 2 slightly more compatible with OpenBSD. So it talks a little bit about hardware next. As with the original Surface Go, adopted for the Wi-Fi only model with 8 gigabytes of RAM and the 128 gigs NVMe SSD. Processor is an 8th generation dual-core Intel Core M38100Y. And tablet measures are not too important here. So it has a resolution of 1920 by 1280 up to 1800 by 1200. Yeah, I guess people can look up the parts about the backlit keyboard and touchpad. What's interesting is for the OpenBSD article in here is the firmware part. The Surface Go's BIOS firmware menu can be entered by holding down the volume up button, then pressing and releasing the power button, releasing the power up when the menu appears. Because that is the way to actually let this thing boot the way you like it. Okay, installing OpenBSD. Due to the previous OpenBSD work on the original Surface Go, most components work as expected because it's the follow-up Surface Go. And so during installation and first boot, they still work as expected. So they did the install on OpenBSD 6.7 using a DD image to a USB stick and entering the BIOS as noted above, and then disable the secure boot to actually make this possible. Then they partitioned the 128 gig SSD and safely deleted the Windows recovery partition because that's not needed anymore. And this takes a lot, well, in comparison, 1 gigabyte for this machine. And so this saves a bit of space here. And after installing OpenBSD, but before rebooting, mount the EFI partition, which is SD0i, and delete the /EFI/Microsoft directory. With pleasure. Without that, it may try to boot the Windows recovery loader, and that's not where you want to go. You want into OpenBSD's loader. So then OpenBSD's EFI loader takes over and then loads by default.
Yeah. They have a nice little tree at the bottom talking about the different components and how they work, or if they work. So the AC adapter works and is detected via the APM command. The ambient light sensor does not work. It's currently behind the PCI Intel sensor hub device that doesn't have a driver in OpenBSD. But the audio works via the HDA. The battery status, again, works via APM. Bluetooth does not work yet. It just shows up as a generic USB device at this point. But it can just be disabled in the BIOS to save battery as well. The camera currently does not seem to work. Apparently front, rear, and IR cameras are all there, but there's no drivers yet, and again, can be disabled to save battery. The gyroscope is behind that Intel sensor hub, and so doesn't have a driver yet, but it would be nice if it could feed the sensor framework and maybe even tell XR&R to rotate your screen when you rotate your laptop. Hibernation works via the uppercase ZZZ command. The micro SD card works. The SSD works nicely with the SK Hynix NVMe device that was included. The Service Pen works as the touchscreen via the IMS driver. Suspend Resume does not appear to work yet. The touchscreen works via the hit over I2C device, IMS. The type cover keyboard somewhat works. There's some notes about until he made some changes to a driver he wrote. I think pressing F2 made it reboot and a couple of weird things. But it does give you 3 levels of backlight control, and it's adjustable by the keyboard itself rather than have to do software. The type cover touchpad works via the UMT driver for 5-finger multi-touch, 2-finger scrolling, and all that kind of stuff. The USB-C works for data and charging. The video works via the Intel DRM Kaby Lake driver. And even has proper S3 suspend and resume. The volume buttons work via the ACPI HID driver, and the Intel AX200 Wi-Fi is supported by the IWX driver, although there's a note here that it loads the firmware, but when it tries to authenticate to a network, it gets a fatal error in the firmware, but he's been working with other OpenBSD developers on that, and so it might be solved by the time you're looking at this.
Next up, we have a FreeBSD Unix for Linux admins article, or sysadmins in particular.
Yeah, so this one says, FreeBSD is Unix for Linux sysadmins. If you've ever installed and explored another Linux distro, and what Linux sysadmin hasn't, then exploring FreeBSD is going to be a somewhat similar experience with a few key differences. While there's no graphical installation, the installation process is straightforward and similar to installing a server-based Linux distro. Just make sure you choose the local unbound package when prompted if you want to do caching local DNS lookups. Following the installation, the directory structure is almost identical to Linux, of course, although you'll find some small differences here and there, like regular home directories end up under /usr/home, although there's a symlink from /home, so it's fine. Standard Unix command like ls, chmod, find, which, ps, nice, ifconfig, netstat, sockstat, etc. Are all there, but they might be slightly different output or switches and so on. And of course you have, reboot and power off and all that kind of thing. But why might you be interested in FreeBSD? The main benefit FreeBSD had over Linux is speed. You thought Linux was fast? Try FreeBSD. It has the fastest IP stack of any operating system. Since it's Unix and you can provide the same services like Samba, Apache, NFS, Nginx, etc., it means you can provide them faster and leaner. FreeBSD has kept to a simple Unix roots model without compromising on features. While Linux configuration gets more and more complex as time goes on, when you start a service, if you want to start a service at boot time, you can just put the line service name _enable equals yes in a text file, and it just works. And this small text file stores 90% of your system configuration, including your IP settings and what services you want to run and with which settings. In short, configuring a FreeBSD system is both fun and addictive. While configuring FreeBSD is easy, it's also incredibly powerful. There are granular security features and system configuration and recovery features in FreeBSD that you won't find in many other operating systems. For those who want to go down that particular rabbit hole, it's well worth your time. And of course, native support for ZFS, the most advanced file system on the planet, is a big plus. So it has sections on system configuration explaining, etcrc.conf and etcdefaultsrc.conf and the etcrc.conf.d directory, how the bootloader is configured, how to load kernel modules, and how to adjust sysctls, how the system boots, how init and RC work and the rc.d scripts, but also the rescue binaries and where log files go. How devices are named, you have DA0 or ADA0 instead of SDA and so on. How NVMe and so on works, partitioning, all that kind of stuff. How to configure your file system, you have NewFS, GrowFS, TuneFS, etc., or ZFS, and how that works. A bit about boot environments, uses and groups. If you're looking for etc shadow, it's actually over here in a much more logically named file, master.password. How the skel directory works for setting up empty home directories and being able to pre-populate those with files. The package command and how easy that is. Configuring additional services like Apache and getting it all working. How to look at netstat and do other interesting things. How ports work if you want to have something slightly different than just the packages. How to use PF and BlackListD and jails. And even how to share ZFS over NFS. And how to enable simple services via inetd or even configure printing. And that's just the first chapter. So
Yeah, there's lots more.
definitely worth reading that if you're mostly a Linux admin and want to kind of get a starter guide specifically targeted for people that are used to Linux and just need to know what's different or why, this utility is actually called that, rather than documentation that assumes you don't know how to administer a machine. Or maybe you do, you just need to, to translate your skills from this other operating system.
Okay. The next article is for the people who actually want to run FreeBSD on the Lenovo ThinkPad T480 and the things that work and, well, probably don't, but there's a good chance they will. It starts with, recently I replaced my 2014 MacBook Air with the Lenovo ThinkPad T480, on which I've installed FreeBSD. Currently 12.1 release. This page documents my setup along with various configuration tweaks and fixes. So the list of working things is the high resolution screen, the WQHD, Wi-Fi, of course, 802.11g, IR and visible light camera with a little wink here at the end, suspend and resume, sound. There's a note about the headphone jack a little later down the road. Trackpad and Trackpoint, as well as the USB ports. Not working, Bluetooth. Apparently causes a hang on reboot and no drivers available. And 802.11ac, no support in FreeBSD yet, but people are working on it, I hear. I don't have any Thunderbolt devices to test and don't have a fingerprint sensor installed. Okay. Then there's a section about...
But, the main components of the laptop are all working out of the box, which is really nice experience.
Yeah, you can start working with that seriously. X11 and Intel graphics. There's a description on how to load the proper module, the i9-15KMS, and had the best success with the XF86 video Intel driver, which gives the default mode setting driver working and has frequent screen tearing. Yes, there's another module, the XF86 video-Intel, and use the SNA acceleration option there with the proper settings in your XOR and that should get this working smoothly. Then the trackpad and trackpoint, there's a couple settings there. Good news is that since the UDEF and libinput was merged in the default XOR driver, trackpad setup is much easier than previously. And there's a separate blog post listed by Michael Mellin, I think that's how you pronounce it. And the cool thing is that to have the trackpoint buttons and trackpad working as expected, there's a couple of sections you also add to your XOR conf input file. And that should give you a smooth ride on the trackpad. The 5G and Wi-Fi networks are next. They won't be visible unless the country code is properly set with the Wi-Fi interface. There's descriptions how to do that in the handbook as well. So you set the country regulation code to your country's two-letter name, and then that should work fine. Suspend and resume. To enable suspend and resume on lid close running X11, you need to add a little sysctl conf.
Well, yeah, so the sysctl makes it so that it auto suspends when you close the lid.
Right, yeah, so that you can just close and don't forget about the rest. Yeah. Then screen brightness can be changed using the kernel module ACPI video, and that's fairly straightforward. Sound is also great on the speakers, but really bad from the headphone jack. Lots of static and distortion, and a lower volume, nothing can be heard. But as of March 2020, this problem is not present in 12.1 stable anymore, or 13 current, so this will come down to your release soonish. camera is also nice and seems to be working, as well as, in this case, i3 window manager. You can pick any window manager you like. And there's a couple sections about how to configure those as well. Cool. List all the configuration settings, everything that you can start your own journey on this laptop with FreeBSD.
Yeah, great help. So this week's episode of BSD Now is brought to you by Tarsnap. We really thank our friends at Tarsnap for helping us keep BSD Now going. And if you need to back up your files, which you do, you probably want those files to be safe and secure. And if you want them to be secure, your only option is Tarsnap. It's the backup platform where you have the source code for the client and can be sure files are being encrypted on your machine with the key only you have before they go to the cloud. So then they go to the cloud and you can get them back later. But again, if anyone doesn't have, without the key that you use to encrypt them, you can't decrypt them and they're no use to anyone. Not even calling can get your files. And so you have to be careful with your key and protect it. But it means that, you can actually trust, or you don't have to care if you can trust the cloud, because all they have are the encrypted versions of your files. Without the key, they're no use. And so it's the only way to be sure your data is safe, because even paranoid people need backups.
Oh, yes, for sure.
Yep. So head over to tarsnap.com/BSDnow and check it out. It's pay as you go. So you can just put in a few dollars and start backing stuff up until you've used up that money. I put in $20 a couple of years ago, and I've been backing up my important business and personal files, 3 times a day, every day, and I'm still going strong.
Yeah, check out that documentation as well as technical details if you really want to dive into it, and then try it out for yourself and see what benefits you get from making secure backups to the cloud.
Yep. And if you need help with, coming up with a backup strategy, there's actually a Tarsnap Mastery book by our friend Michael W. Lucas that walks through how to actually deploy it correctly and, what some good suggested backup strategies are.
All right, you may be wondering, where are the Beastie Bits this week? Well, we thought we would catch up on a couple of feedback and questions this time. So don't worry, this section will be coming back next time. But this time we will focus a little bit more on feedback and questions. So we get the double dose of people getting answers. The first one is Benjamin with a ZFS question. Good morning, Alan and Benedict. Firstly, I'm in the Waterloo area, and I'm sorry that I was not able to make it to the first BSD meetup for a few weeks, or a few weeks ago. Scheduled maintenance at work got in the way. Sometimes that's unavoidable.
Yeah, we've been doing them virtually lately, so you can just call in at the right time.
Yes, at work even, if you can switch between the two tasks. So secondly, I have a question regarding ZFS. Here's the one that I haven't really been able to locate an answer for because I'm not sure how to filter out the noise. I keep reading in places that when ZFS is storing small or smaller files, it doesn't bother to calculate the chunks to store across different drives, but simply just stores the complete copy of the files on the drives. What is the threshold for this, and is it configurable? Most of my files are not going to fit into this scheme as they are larger files, but I'm curious to know what the answer is.
The way RAID-Z works is you write chunks to each disk in kind of columns. So this is explained well, actually, in one of the precursors to the Jim Salter article we talked about earlier in the show. That also fits with your question here. But in general, the smallest chunk that ZFS can put on a disk is 1 sector, which, nowadays is mostly 4 kilobytes. So if you have an 8 kilobyte file, then with RAID-Z, ZFS is going to write that to 2 different disks, or actually more than that, because you also have to have the parity. So if you have, say, a RAID-Z 2, if you have a file that's 4 kilobytes or less, it's actually going to be spread across 3 disks, right? You're going to write the parity and the second parity, one each to a different disk, disk 0 and disk 1, and then disk 2 is going to hold the 4 kilobytes. If you have an 8 kilobyte file, it's going to be spread out slightly differently. You're going to have the 2 parity blocks, then your 2 data blocks, right? The first 4K and the second 4K of that 8K file, but that makes a total of 4 blocks. ZFS always rounds its allocations up to n plus 1 sectors, where n is the parity level. So 2 plus 1. And in our case, it's 2, RAID Z2. So all allocations have to be divisible by 3 in a RAID Z2. Otherwise, if you had those 4 blocks and you eventually freed those and then wrote a new 4K file, it would use 3 of those 4 blocks, and that would leave 1 block sandwiched between other allocations, and you'd never be able to write to it. So the reason why it makes sure that every allocation is a multiple of 3 is 3 is the smallest number of sectors that ZFS can write out, right? Because in a RAID Z2, because you have the data and 2 parity blocks. So if you have an 8 kilobyte file, it's going to write 2 parity blocks, 2 data blocks, and then it's going to purposely leave 2 padding blocks so that now this allocation, instead of being 4, is 6, because 6 is divisible by 3. So if you have small files, a bunch of small files together, if you have, say, an 8 wide RAID Z2 and you write 2 4 kilobyte files, you're going to write 3 blocks, 1 block each, the first 3 disks, and that'll be the first file. And then the next 3 disks will take, the 2 parity and the 1 data block of the next file, and it'll keep going, and it'll still use all of the disks. So only files less than 4K are going to be where it doesn't use all of the disks, or where the only time it's not going to use every disk in the array to store your file is if your file is less than the smallest sector size, which is usually 4K, but could be 512 bytes depending on your disks, times the number of disks minus the amount of parity. So if you have an 8 wide RAID Z2, then your file needs to be at least 6 times 4 kilobytes, so 24 kilobytes, in order to use all 8 disks in the array. But it doesn't really matter, because if you're writing really small files, you're probably writing many of them, and if you're writing many of them, you're using all the disks anyway.
There's a second part about a Reddit thread basically revolving about copy on write being redirect on write, and there's a bit of a controversy there, and what our thoughts would be. Basically saying that redirect and copy on write is basically just saying, oh, the data you're looking for is over there, and just redirects you to a different part of the disk.
No, not really. Like, the block pointer points to somewhere else, but you don't update the block pointer in place either. You copy it to a different place too. And then, so the only thing that actually gets overwritten in ZFS directly is the uber block, which is the very, very, very top block pointer that points to the meta object set, which is like your list of data sets, which then eventually point to the files. And those, there's a ring buffer, basically, a loop of them. And we just keep overwriting the oldest one in place, so that if the power goes out while we were in the middle of an update, when the bootloader boots up, it reads the newest one, finds out the checksum doesn't match, and then reads the second newest one, finds out the checksum does match, and imports that version of the pool. And that's how ZFS never needs to do something like an FSCK, because it didn't overwrite anything in place, it can just use the older version of the block that hadn't been only partially written.
Okay. That should distinguish that properly. So thanks for your feedback and keep listening. Next is Brad with a question about the swap pager errors he's seeing. Goes like this. Hello, Benedict, JT, and Alan. I'm running into an issue and I'm not sure if it is actually affecting performance on my FreeBSD 12.1 release box. I'm running ZFS with a mirrored pair of 250 gigs SSD as my primary pool and a pair of 1 terabyte spinning drives as the pool for all my big and thrashy stuff. What I have noticed is that occasionally my performance will get really bad, my graphics will get really choppy, and even though I appear, according to HTOP, to be 5.2 gigabytes of 16 gigs of RAM, my swap will be almost full. Well, tonight when I rebooted, I saw a number of messages like, failed swap pager, get swap space. I've seen those. I've seen some preliminary web searches and found a bug report from 2009 in the 2018 mailing list thread. The latter talks about the ZFS ARC cache, and thus by magic it turns into a ZFS question. Is this a ZFS problem? How do I determine it? Unfortunately, I just rebooted this evening, which is when I saw the swap pager get swap space messages.
Yeah, so those get swap space messages are cases where FreeBSD is trying to get more swap space, but your swap is already full. I don't know about this HTOP output. I can see that it says that it looks like you have 0K free in swap, but the regular FreeBSD top will give you much more useful information about how your memory is used. And so that would be helpful to have to know what your problem is. I think there was some stuff with 12.1 where it would use swap a little more aggressively than it needed to, but I've not really had any trouble with it. You might want to look at what your ZFS ARC max size is and adjust that. There's also another tunable called vfs.zfs.arc_free_target, which is how much memory ZFS should aim to leave free for other things. It's complicated though, because that one is not in bytes, it's in pages, which is 4 kilobytes on most machines. And so setting that value higher will make sure that when the amount of free memory gets low, ZFS will start shrinking the arc automatically. But if you actually have 5 gigs of memory free already, then that's probably not the problem. But yeah, that's probably the easiest way to debug this one would be when you see the problem, run regular top in FreeBSD. So top-o res, and that will give you the output of top sorted by which programs have the most amount of memory in use. And the top bit will explain how the memory in the system is broken down into different pools, and also how much of that is being used by ZFS. Is too much of your memory wired versus not, and so on will help answer the question.
Okay, that should shed some light. Thanks for this question. And Brandon is next with a gaming-related question, I'd say. Brandon writes, "Hi guys, great podcast. It's very informative. Thank you. I'm a total BSD noob looking to move from Windows to FreeBSD. I haven't yet. FreeBSD has everything I would need, either natively or through ports. There's just one issue, gaming. Ideally, I would like to run Windows in a virtual machine to play AAA games, but I have no idea how to do it. I have listened to your podcast on GPU pass-through and have looked at some online posts, but it seems a bit hit and miss. My only alternative is to run Linux and use Wine. Any advice would be really appreciated."
So if you're willing to use Wine, most of that will work on FreeBSD as well. Like I know many people have been playing games via Steam under the Windows version of games via Steam on FreeBSD, as opposed to the native Steam on Linux. So yeah, if games are known to work under Wine, it's likely you can get them to work under FreeBSD without too much hassle. For the GPU pass-through thing, I wish I knew more about that. In general, I think there was some progress in getting it to work as long as you actually had a video card FreeBSD could use, and then separately the discrete, gaming video card that you could pass through into the VM. Although I think there might have been an issue where, it only worked the first time after a reboot because the VM couldn't properly reset the graphics card. And so you'd have to reboot before you could run the VM with the graphics again. It's definitely a thing a lot of people want, but it's also not necessarily that big of a priority for developers because it's not really something that will unlock a bunch of commercial opportunities per se. Gaming is hard.
Yeah, it's always chasing the latest technology.
Most of the stuff under Wine you can do in FreeBSD.
Yeah, it definitely gives you a couple of games already.
And if you do manage to get a bunch of the games working under Wine, it'd be great to do a blog post just so that more people have some of the steps to follow. All right. I think that's about all the time we have for questions this week. Thank you very much for joining us. But if you would like to have your question answered on the show, please do write to us at feedback@bsdnow.tv and give us your question and so on, and we will try to get to it again soon.
Yeah, you will listen to us definitely next week.